As you know, the world has entered the era of Internet. This article let us understand the meaning of the Internet of Things and Industrial 4.0. The article is to review technological trends and the impact they may have on industrial communication. First, review the impact of IoT and CPSS on industrial automation from an Industry 4.0 perspective. Then give a survey of the current state of work on Ethernet time-sensitive networking, and next shed light on the role of fifth-generation telecom networks in automation. Moreover, point out the need for harmonization beyond networking. Now let's turn over discussing what is the Internet of Things. Generally speaking, the Internet of Things is the network of physical devices, vehicles, home appliances and other items embedded with electronics, software, sensors, actuators, and connectivity which enables these objects to connect and exchange data.
The development time domain of communication technologies. The communication research starts from between 1960s to 1970s. It is just focused on computer network. From 1990s to 2010s, the communication technologies developed rapidly. A lot of technologies has been generated in these years. 5G technology is developing now. It could help the communication development.
When Internet technology became popular to facilitate information exchange, a multitude of industrial communication networks evolved over the years. In Germany, the definition of the Industry 4.0 concept was developed originally, which applying the ideas of CPSS and IoT to the industrial automation. Furthermore, IoT, CPS, and the emerging tactile Internet are penetrating industrial automation and changing the angles from which people look at automation systems. From a communications perspective, IoT and CPSS rely largely on mobile Internet. For example, telecommunication networks.
Digital transformation is the core of the fourth industrial evolution, and 5G network infrastructures will be key supporting assets. In the next decade, the manufacturing industry is expected to evolve toward a distributed organization of production, with connected goods, low energy processes, collaborative robots, and integrated manufacturing. 5G leads to integrate different enabling technologies. For example, mobile, satellite, optical, IoT, and CPS. The communication in industrial automation systems are complex regarding real-time, mobility, safety, and security, explosion protection, availability, and so forth.
Today, RTE has become a standard in the industrial automation domain. The existing RTE solutions are based on fast Ethernet and can be divided into three classes, which differ in the achieved real-time performance and the necessary extensions of the IEEE A02 standards. In Class A, the real-time services are realized above a transport layer with cycle times in range of 100 milliseconds. In Class B, the real-time services are realized directly on top of the media access control layer by using approaches like prioritization and virtual local area network, tagging to separate real-time data from best effort traffic. The achievable cycle time using fast Ethernet is in the range of 10 milliseconds. Class C is the most powerful class, where the real-time communication capabilities are achieved by modifications of the Ethernet MAC layer, like strict communication scheduling and high-precision clock synchronization according to IEEE 1588 in the terminal devices as well as in the bridges. The achievable cycle time lies below 1 millisecond. The IEEE A02.3 Residential Ethernet Subgroup was formed in 2004 to explore the need for an Ethernet specification for residential applications. This activity was merged into the IEEE A02.1 AVB task group in 2005. The most distinctive feature of AVB is the ability to guarantee uptime bounds to all priorities of all data streams, which is an improvement in comparison with standard Ethernet. With the completion of the AVB standard in 2012, the task group changed its name to TSN to better reflect the new enlarged scope of its standards due to its expanded target applications. The IEEE TSN working group currently aims to improve the reliability and real-time capabilities of standard Ethernet. Although the work on TSN has not yet been completed, the potential for industrial automation applications is appealing. Contrary to previous development toward RTE requirements, low latency is not put on top of the existing standard. This can be expected to make a huge difference in technology acceptance.
One of the further challenges of 5G network is accommodating a wide range of use cases in terms of latency and resilience. Another is providing end-to-end network to fulfill vertical-specific requirements. The number of wireless applications and devices are increasing to manage the spectrum. Defining generic communications services via network harmonization is one of the challenges to face. Industrial communication systems underwent a long evolution with many influences from technologies from outside the actual automation domain. From an application point of view, industrial communication needs to fulfill the specific technology which is rely on service providers guaranteeing codes for the intended application. From a communication provider view, the adoption of our technologies need to be evaluated and tailored to industrial automation needs.